As now we know that the attempt of classification was made by first the early chemist, then the Daubonnier came, this thing, and after that there was an attempt made by Newland on the basis of musical note. We have already studied an interesting classification, and the next classification, but somehow due to some reasons those classifications were failed. So the next attempt, who made an history in the chemistry, who made a great mark in the chemistry, who made a great contribution in the chemistry, was done by Dmitry Mendeleev, who was a professor, in Petersburg University as chemistry professor in Moscow. And you know, he made a great mark. He was able to classify, successfully able to classify 63 elements, because when he classified the elements, 63 elements were known, and he was able to classify those 63 elements in a tabular form which was clearly understood by the all. And even he made a very bold prediction. He even predicted the existence of certain elements who were not discovered at that moment. So that was a bold prediction. And even his this thing, when he classified the elements, he did the classification he did was in a very practical way. So let me tell you what the idea came to his mind and how he did. See, at that moment 63 elements were known, as I've told you. So what he did, he took 63 cards. He took 63 cards. Then what he did, he wrote properties of each element, like he picked one element, then how it was looking, he just wrote on that card. And chemically he reacted that element with hydrogen and oxygen, and the type of hydride and oxide it was forming, he wrote that also on the card. So he wrote, again I am repeating, he wrote the physical properties that was looking like, he picked one element, how physically it was looking. So he just wrote that. And when he reacted that element with hydrogen and oxide, then what kind of oxide or hydride it was forming, he wrote the formula for that also. So likewise he wrote these properties and the formula of hydride and oxide for 63 elements on 63 different cards. Then what he did, he wrote the property and the hydride oxide formula, and just clipped the card on the wall. And this he did, likewise 63 cards were pinned on the wall. Then he started sorting out the cards which were similar, like he was looking like, yeah, this metal is hard, found to be hard, this is also hard, so somehow less harder than it, he just clamped that on this. So this is why likewise he started sorting out cards with similar properties. And as he was doing that, you know, accidentally the elements got arranged in order of increasing atomic weights and also the similarity in properties. This led to the formulation of his periodic table, that is Mendeleev periodic table. So how he did, he arranged the elements in a proper tabular form called as periodic table. I repeat, called as periodic table. So that means periodic table is a tabular chart which contains the you can say the vertical columns were called as the vertical groups, and it consists of horizontal rows called as periods. So he was able to classify 63 elements. 63 elements, you need to remember the figure. 63 elements in a proper tabular form, that is called as periodic table, that comprise of periods, horizontal rows, and the vertical column called as groups. So he formulated the law also, because as he was pinning the cards together, so those elements, as I've told you, got automatically arranged in the increasing atomic weights. So this, and even the periodicity in the properties was observed. Now what is periodicity? You must be thinking the ma'am is using the word periodicity. What does it actually means? Periodicity means reoccurrence of properties at regular intervals of time. So the reoccurrence occur only if the elements resemble among themselves. So it led to the formulation of the law that is called as Mendeleev periodic law. So what does it state? It states that the properties of elements, whether the properties are physical or whether the properties are chemical, the properties of elements are periodic function of their atomic weights. So it led to the formulation of Mendeleev's periodic table, that we'll be doing it now, that how he arranged the elements in the tabular form. See, it was Mendeleev periodic table, the main contribution. See how it, what does it comprise of? This Mendeleev periodic table, first of all, comprise of, as I've told you, this thing, the vertical column called as groups and the horizontal rows called as periods, like you can see that. So how many groups were there? There were 9 groups, 0 to 8. he named those groups in a Roman one. You can see 0, 1, 2, 3, 4, 5, 6, 7, 8 likewise. So he started with 0 and ended up at 8, so total of 9 groups were there. And what about periods? The periods were 7 periods were there. You can see that likewise. So it comprised of the vertical columns, that is called as groups, 0 to numbered as 0 to 8, and the periods 1 to 7. So he made an attempt to classify these 63 elements in the way as you can see on the board. You must, I think it's clear to you that how, see, in a group it is helium, neon, argon, krypton, xenon, and likewise in the period they are arranged in such a way. Now, what is the contribution? How he explained that how they are arranged or how they are put into the, they are clubbed into the table. So, or you can say, what was the advantage to us that this table gave us? So, firstly, it made the study systematic. It made the study systematic. How? See, in the first group we can see lithium, sodium, potassium, copper and this together. That means if we know that, if I know that copper belongs to the first group along with lithium and sodium and potassium, so if I have the idea of the property of sodium, I can easily have an idea for the element which belongs to the same group, right? So it made the study systematic. By knowing that which element belongs to which group, we can know, we can just recall the properties of that group, and if we know that this element belongs to certain group, we can recall all those properties, because all those properties will be applicable to those, that particular element also which is present in that group. So on the as a whole, I want to say that it made the study systematic. It made the study easier. Second contribution towards, second advantage of this periodic table which this periodic table gave us was that he left spaces at certain places. He left spaces at certain places, like the place was there, there was a place, actually this periodic table has those filled places that is indicated. See, all those places which are indicated this purple with purple ones were actually the vacant spaces which he left in the periodic table, and that means why he left. Now the question comes, why he left those vacant spaces? Actually, when he was arranging the elements according to the properties and according to the atomic mass, he just made a prediction. He just assumed that there is a kind of element which is not present now, but in future we'll get that certain element whose properties will lie between those elements. And actually after the Mendeleev gave the periodic table, those elements were discovered and they actually filled those gaps which were left by the Mendeleev, and it was the very bold prediction. Everybody was so shocked that how Mendeleev got to know about those unpredicted elements, those were not discovered at that moment, and he actually named those vacant spaces as Eka aluminium, Eka boron, that means next to it, and just left the vacant space there, so that when later on those elements will be discovered, so nobody has to change this periodic table. He was so confident, he just want that those elements will be definitely predicted and they can be just picked and placed at that vacant space which is left by the Mendeleev. And as I've told you that it really happened, it really happened. Scandium was the one who was called as this thing, who filled that vacant space. Gallium was the one who filled that vacant space. So that was the very bold prediction. So always this is a very important question that anybody can ask you, that why Mendeleev left spaces in periodic table. So you should know that he made a bold prediction. He even predicted the existence of those undiscovered elements, and those elements were discovered at later stage and filled those vacant spaces which were called as Eka aluminium or Eka such element. You can see that the places which are marked with purple areas were discovered later, but it was these elements, their existence was predicted before by Mendeleev, before their discovery, and later on really those elements were discovered and they filled those spaces, and it was a great achievement. It was a great achievement that you don't have certain thing in nature and still you are predicting it, and still it is being discovered and it's directly placed into this, right? So second main contribution is that first it made the systematic study, and second it just filled the vacant space left in the gaps. He made the prediction of undiscovered elements, right? And thirdly, he corrected the atomic mass of certain elements. While he was arranging, he get to know that certain elements do not have the right atomic mass. For example, I take an example for you. You should know that at least one example you need to know that in which case he corrected the atomic mass. So right, while he was arranging the elements, so beryllium was assigned an atomic mass of 13.5. So according to it, it should be placed between carbon and nitrogen, but the properties did not match. The position of beryllium between carbon and nitrogen was not justified. So he just went into deep and he said that my prediction can't be wrong, that the place of beryllium does not lie between carbon and nitrogen, it may have the wrong atomic mass. He just corrected the atomic mass, and actually he was right. When he corrected the atomic mass of the beryllium came out to be 9, means its position lies between the lithium and boron, and he was correct in his assumption. The atomic mass of the beryllium was actually wrong before. It was not 13.5, it is 9. So see, it is also a bold prediction that he is making a fundamental property wrong, that yeah, this is calculated to be wrong and it has to be recorrect, and I am confident in my arrangement of elements showing the periodic relationship between them. And so he made a great contribution in that way. So 3 things that made a mark in the history of the chemistry is when he was classifying that first systematic study, was the first scientist who made classifying the 63 elements in a proper manner, and secondly he made the bold prediction that I told you, that he discovered, he left the spaces in the periodic table as he was so confident, and also predicted the discoveries of those undiscovered elements which later on really discovered and got positioned at the places which were left by the Mendeleev. And third, he corrected the atomic mass of many elements. So it is a great achievement. But as he did the great achievement also, but there were few lacking points. But still, don't forget, he made a great achievement, because today's this table is being refined as modern periodic table, but still the effort which came from Mendeleev only. So I am just listing the limitation which he had in the periodic table, which he failed to explain, which are taken as the drawbacks of Mendeleev periodic table. So just listen to it carefully.